Chapter 7, Lesson 7 is on page 336, and we're going to use the information we've learned so far to fit equations to real-world data. These equations are approximations to the data. Things are not as exact as they are in the problems we were doing previously. Here are some data in problem 9. The motel owner, miles, and cost. So the further you away from the city, the cheaper it is to rent a hotel, which sort of makes sense. So the data is in that table in problem number 9, and I went ahead and made a graph because that was the first thing we had to do. And in the problem it said, make sure that instead of calling things X, we're going to call things D. And they said label that on the x-axis. And then instead of y, we were going to call those C and put those on the y-axis. So here's my data. I changed the scales. This goes 10, 20, 30, 40, 50, 60, 70, 80. And on the x-axis, or the distance, I changed it to miles. 1, 2, 3, 4, 5, 6. So the first point was 1, 80, 2, 75, 2, 55, 3, 60, and 3, 45, 4, 50, 5, 40, 5, 50, and the last point was 6, 35. So here's the data. Obviously it's not a straight line, but we're going to try to use this equation y is equal to mx plus b to see if we can fit an equation. So the first thing we have to do is stare at the data and see if we can come up with a place by connecting the dots that would give us what we think is the best looking shape of this equation. So I'm going to choose, you can choose any points you'd like, but I'm going to choose this one and that one because I think those best represent what this graph's going to look like. Some points are below the graph, some points are above the line. That's okay. We're just making an approximation. So I think what I'm going to do is highlight the 2 points. I'm going to use this point and I'm going to use this point and see what we can do from there. So the 2 points we've chosen are 1, 80 and 5, 40. Okay? So let's see what we can do with that. Let's see if we can calculate the slope. So the slope is going to be the y's over the x's. So the slope is going to be 80 take away 40 on the top. Those are the y's. Let's put that up here. Let's put the x's on the bottom. And the x's is going to be 1 minus 5. So this looks like 40 over minus 4. So the slope turns out to be minus 10 over 1. So we're almost there with our equation. I'm going to choose from this 1, 80. I can use either of the 2 points, remember. I'm going to choose x is equal to 1 and y is equal to 80 because it makes life easier for me. I could have chosen 540. Either of the 2 points I could choose. So I'm going to use my equation y is equal to let's back up. Y is equal to mx plus b. We're going to plug in the stuff that we have. We've got a minus 10. We've got a 1. And we've got an 80. So let's see what we can do. So this looks like 80 is equal to minus 10 times 1 plus b. So this looks like 80 is equal to minus 10 plus b. Or if we add 10 to both sides, b turns out to be 90. So we got one more piece of information. We know now where it crosses the y-axis. Well, let's finally use this information and write our equation in slope-intercept form. Y is equal to, one more time, mx plus b. Well, finally we have an equation. Y is equal to minus 10x plus 90. So there's my equation as I fitted it to this set of data. Just for review, you look at the data, make a graph. Best fit where you think the line should go through. Pick 2 of those points. I picked the first one and this one at 5, 40. I calculated the slope. I used the slope-intercept form of the equation to find the actual equation. And in my estimation, y is equal to minus 10x plus 9. Yours may differ depending on the points that you have. The answer in the back of the book is slightly different than mine, but the approximation is still valid. Thanks so much. We'll see you guys all tomorrow.